Hey, my name is Kayode Sanni, and I'm from University of Maryland, Baltimore County. And for this summer, 2010, I was doing some research at the University of Michigan under Dr. Edwin Olson at the April Lab.
I'm Kerry Luke, also from the University of Maryland, Baltimore County, and I'm working in the April lab like Kayode under Dr. Edwin Olson in the Computer Science and Computer Engineering Department. And so one of the problem we're working on is that we're trying to develop a team of robots that would be able to accomplish tasks normally done by much larger robots and much more complex. But we're trying to get like a team to work together in order to do those tasks. And so robots such as seen on the screen here. And one of the problems that we've occurred is that the robots themselves don't actually know where they are in an environment. And so our task was to develop a way to locate, identify, and track these robots as they go around in the environment. And so the way we did it was we developed a system of using LED lights attached to the individual robots themselves, and we were tracking their movement using cameras. And so with this implementation, we discovered that not only were we able to track the robots and identify them, we can also deliver other types of messages using their blinking patterns, like internal status errors, or let's say the robot has flipped over or had some other kind of problem. We've been able to detect that, and so that's what we're doing. The way we're doing it is we actually have the camera image, and we've been doing image processing, and he'll tell you more about that.
All right, so we have to find the LED lights in the image, and we go about this, like he said, through image processing. So if you take a look at our next picture, we have this unedited version of a picture which has a robot and LED light mounted on top of it. All right, so we use image processing, which pretty much is the manipulation and the editing of pixels in the image to bring about, I don't know, a better quality of the image, or just to pronounce or exaggerate certain parts of the image. And so after doing that, we get rid of the irrelevant spots. So we have something like this where we can see that we have the blue, the red, but unfortunately the green didn't come out right. But even though we do see the LEDs, we also do get the irrelevant spots too, which we don't need. So we have to, do a little bit further analysis to get the exact LEDs. All right. So then we have to find the midpoints of the LED lights, and we do this by using a common algorithm called union find. And this works by we group them up by ID numbers based on their colors. If they're similar in color and close in proximity, then we group them up. And then, we find the midpoints, and this is what we've done here. But we've gotten rid of the other irrelevant spots that were there by we check a series of images, and if they don't bring out the patterns that we have encoded into LED lights, LED patterns, then we know that those are not LED lights, so we can automatically get rid of them. And then we know that right here, right here, right here, we have our LED lights, and those are our midpoints.
So the way we go about actually tracking the robots is by when we have the midpoints of different LEDs, we measure their displacement over several frames, and so we're able to judge the velocity of the robots and their movements. Also, in order to identify them using blinking patterns, we have to measure the changes in their in the actual light. So in this picture here, normally this center one would be the one that we have blinking, and so we would track the robots using the outside ones, and then for the center one we'd see if it's actually changing in value over time, like if it's disappearing in one frame and if it's reappearing in the other frame, and we record those values, and so we're able to extrapolate certain information from that data.
All right. So we still have work to do because our project isn't done, and we have to work on solving problems such as what if the robots are moving? How do we keep the exact points at which they are? And how do we localize, and pinpoint exact locations where they are in space? And, we also come across other problems like, what if the background changes or the brightness changes? How do we, how is this consistent? Will we be able to pick up the same image, or will something be flustered out? And so, we come across these problems, and we're going to tackle them later on.